All right, hey guys, just going to go through the practice test that you guys are going to get given in class soon. For question 1, we are asked about finding simple interest. How much interest, more specifically, is what we're asked to find. That cues me that I need to use the I equals PRT formula, which means I need to find my principal, which I can see is 3,800. I need my rate, which is 3.9%, which most of us are going to be converting to 0.039. And we need our time, which is going to be 1 year. So just one. So then when it comes to working this out, we are multiplying these three numbers together as the formula suggests. So we're going to have 3,800 times 0.039 times 1. And this is, of course, going to give us a dollar amount. I just need to go grab my calculator. Give me 1 sec. All right, thanks for waiting, guys. So that should give us $148.20. All right, for this pair of similar triangles, we have to calculate some of the missing lengths. As I can see, my missing lengths are x and y. Now, there's multiple ways we can do these. First thing that I'm going to do, if you remember, is find a pair of corresponding sides. So that's going to be the 9 and the 3. And I usually draw my arrow towards where the unknowns are, which, as you can see, is on this left side triangle. So going from 9 to 3, well, I'm actually dividing by 3. Or I'm multiplying by 1 over 3. So if you looked at this question in terms of, scale factor, you would find that it's 3 over 9 with that pair of corresponding sides, which is 1 over 3. So it's dividing by 3, or we have been looking at it in terms of multiplying also. So that's times by 1 over 3. And so then if we wanted to get from 15 to x, that's another corresponding side, we would say that x equals 15 times the scale factor, or divided by 3, so it's going to be 5. And same for y, it's going to be 12 times the scale factor, which will give us 4. So you should get x equals 5, y equals 4. Multiple ways you can do it. That's just one of them, guys. All right, for this one here, we have to find x, and I have to find y. So this is actually a bit of a tough one because we have to go both ways. You can see x and y are on opposite triangles. So let's just focus on x first, right? If I'm focusing on x, I'm sort of going from 22 to 11. I'm going sort of that direction, which is another divide by 2, or that would be the same as saying times by 1 over 2. Once again, if you were to work out the scale factor, going that direction, just to be clear, the direction matters, going that direction, it would be 11 over 22. So a half. So in this case for x, we would go from 24 to x, multiplying that by a half. So x is going to be equal to 24 times a half. Half of 24 is just 12. Okay, so that's our answer for 12. Now, if we were to look at it the other way, because we need to find y now, right? So we need to find y. For y, the direction I'd be looking at it would be that sort of direction. And so if we looked at it going that way, well, I'm actually multiplying by 2. So in this case, the scale factor would be 22 over 11, which is 2. And if you've forgotten why the scale factor is different in each case, whichever number, so this is my corresponding pair, the 22 and 11, which you can see is what ends up in these fractions. Whichever number is at the arrowhead end of the arrows, like the direction we're going, is what would go on top of the scale factor. All right, whichever one is got the unknown on it, sort of thing. So anyway, so we're multiplying by 2, which you can see gives us, so for y, it's going to be 8 times 2. So it's going to be 16. So if you got y equals 16, and x equals 12 for this one. Very well done. Okay. And then on the previous one, it was y equals 5, y equals 4. All right, next question. For these pair, we need to find the scale factor and find the missing length. So on this particular question, there's my missing length. To get from like 16 to 4, because that's a pair of corresponding sides, right? We're sort of like dividing by 4, which once again would be the same as, if we think about it in terms of multiplying, would be the same as multiplying by 1 over 4. Same the way that if I'm going from the 20, that's not a corresponding pair. That's a corresponding pair. 24 to 6 is also the same as dividing by 4. And just to be clear, guys, that is the same as multiplying by 1 over 4. So anyway, so we're multiplying by 1 over 4 to get from one side to the other. So let's have a look. What's my corresponding side with the unknown side? That's this one over here. So to go from 20 to the unknown, we have to multiply by 1 over 4. The unknown side is going to be equal to 20 times by 1 over 4, which is the same as dividing 20 by 4, so it is 5. The unknown side is worth 5. Okay, so when it asks for the scale factor, like part A here, find the scale factor, that was my answer there. Right, the scale factor is 1 over 4. And when it asks for the missing length, that's my answer there for part B, so to speak. All right, Sophie's borrowed $8,200 at a simple interest rate of 4.8% for 2 years. How much interest will Sophie pay? Let's start there. Let's pretend that's like part A. For part A, we have P equals 8,200. We have R equals 0.048 and time equals 2. Putting that together into the formula, we get 8,200 times 0.048 times 2. And this will give me, just whilst I'm throwing this in, guys, just a reminder that you do need to be showing working out like this in the test for me to give you full marks, okay? All right, part B, what is the total amount she has to repay? So for part B, the total amount is represented by this formula here, which you should have on your page of notes. A equals P plus I. Well, the principal amount we identified earlier was 8,200, so we'll replace that with 8,200. And then you've just found that the interest was this amount here, so we're going to add on $787.20, giving me a final amount of $8,987.20. Cool. So that's part B done. And then for part C, and I'm going off the page a little bit here, guys. If this was part C here, if she makes equal monthly repayment over 2 years, so that's the terminal loan, so nothing special going on there, what is each repayment going to be worth? Well, the repayments, let's have a look. Over 2 years, there are 24 months, right? So 2 times 12 would give me 24 months, which means over the 12 years, she's going to make 24 payments to pay all this back. So if we take the amount, which was $8,987.20, divide that up into 24 pieces, we are going to get that she is paying $374.47 each time, roughly. It is a recurring decimal that I've rounded there. It is 467, but roughly 47 cents. Okay. All right. Question 5. A ramp design creates two similar right angle triangles. The smaller triangle has a height of 1.2 meters and a base of 2.4 meters. The larger triangle has a base of 6 meters. So we got 2 ramps. So ramps will usually look a little bit like this, right? And it does say in the question that they are right angle triangles, right? So that's always handy. So we've got a big ramp and a bit of a smaller ramp. All right, so I know they're not great drawings. It's a little bit hard on the iPad. For the smaller one, we can see that we've got a height of 1.2 meters. So I'll put the 1.2 there. and a base of 2.4. So we'll put the 2.4 there. And then for the bigger triangle, we've got a base of 6 meters. So I'll put the 6 here. And we've got a find the height, how tall. So I'll label that X, right? Now, the unknown is on the left-hand side, so we're going that sort of direction there. If I was then to find my scale factor, well, I need a pair of corresponding sides first, which is going to be the bases. If I was to find my scale factor, that is going to be 6 divided by 2.4, which, just as a reminder, in the calculator, you can just straight up do 6 divided by 2.4, and we will get 2.5. So this is telling me that this larger ramp is 2.5 times bigger, which means to find the unknown side, I need to take its corresponding side, the 1.2, and multiply that by the scale factor of 2.5, and we end up with 3. X equals 3. All right, we're making good progress. Question 6, a 1.5 meter pole casts a shadow of 2 meters. At the same time, a tree casts a shadow of 8 meters. We need to draw some diagrams. All right, so I've got my little light pole. All right, I know that's not super artistic, right? But let's pretend that's my light pole, and that is 1.5 meters, and it's casting a shadow of 2 meters. All right, and just for argument's sake, we're just going to throw in the third part of the triangle there. Then we've also got a tree. All right. We've got a tree. We don't know the height of the tree. That's actually what we're going to find, as you can see here. So I'm just going to label that as X. And the tree has a shadow that is 8 meters long. And so once again, we have this triangular shape here. All right. So if we're trying to find the unknown side. So I've drawn my 2 labeled diagrams. Now I need to find the height of the tree. If I'm trying to do that, I need to match up a pair of corresponding sides. And I can see to get from 2 to 8, I'm multiplying by 4. So that's going to be my scale factor. It's going to be multiplying by 4. This tells me that to get from 1.5 to X, I also need to multiply by 4. So 1.5 times 4 is going to give me X. So we should find that X is equal to 6. And of course, this question has units, so we'll make sure that we include our units. Meters, probably not a bad idea to just go back and double check. Yeah, so this question here definitely should have had some units as well. Same with this question here, 5 meters. And those other questions, we didn't have any units. Okay. Question 7, we need to solve for X and Y in the following similar triangles. This looks very tricky. We are going to redraw these triangles. So let's take this top triangle here, right? And let's redraw that so that it looks like this. And I can see that I'm going to have sort of a pink angle up the top here, sort of a blue angle in the corner here, and a green angle over here, which leaves me with then labeling the dimensions. So I can see up the top there between the blue and green angles, I've got 13 centimeters. And then between the blue and pink angles, so this side here, I have 8 centimeters. Right, it's between the blue and pink angles, and then between the green and pink angles, I have 10 centimeters. All right, and so now I can forget that triangle exists, and I can just look at it the way that I've drawn it. And we're solving for X and for Y. So let's use our pair of corresponding sides here. Let's recognize that the scale factor to get from there to there is times 2. Right, scale factor is times 2, which means to get from 13 to Y, we need to multiply by 2. So Y is going to be 26 centimeters. And then to get from 8 to x, we need to multiply by 2. So x is going to be 16 centimeters. Cool. All right, we've got another one like this. This time, we've sort of got like a small triangle inside of a big triangle, so a little bit tougher to redraw potentially. I'm actually just going to redraw the big one. So we'll have 25, we'll have the, oh, sorry, that is not the blue angle. We'll have the blue angle here, the green angle here. All right, hey guys, I know I was saying something, but I've had to stop and restart recording this video. So picking back up where I believe I would have left off, we've got to redraw this like big triangle here. And so you can see I've drawn the base as 25, and then along this length here, you can see I've got y and 18, right? So it's y and 18 centimeters, so to speak. So it's like y plus 18. And then similarly on the other side, it's 12 and x. So it's going to be 12 plus x, right? And now we can almost sort of ignore the bottom half of this triangle, right? We've redrawn it over on the right hand side there. So now I've just got the smaller triangle on the left, the bigger one on the right. Now if I'm drawing my arrow towards where the unknowns are, well, the unknowns are all on the right. So we think about it as if we're heading this way. I've got a pair of corresponding sides in 15 and 25. So when I'm finding my scale factor, I'm going to put that as, well, remember, whatever's on the arrowhead side. So in this case, the 25 is on the arrowhead side, goes on top. So I'm going to do that as 25 on 15, which if you do 25 divided by 15 in your calculator, you'll get about 1.67. After we've gotten that, that tells us that to get from this triangle to the other one, it's become 1.67 times larger. So when I look at another pair of corresponding sides, let's say 18 and y plus 18, this tells me that 18 times 1.67 is going to become that other side, y plus 18. Okay, now 18 times 1.67, that's going to be 30 equals y plus 18. And so now the question becomes, well, what plus 18, this y being the what plus 18 is going to give me 30? Well, that what has to be 12, right? So we got 12 there. For the other thing we've got to solve for here, we've got a pair of corresponding sides there and there. So putting them together, we would end up with 12 times 1.67 equals 12 plus x, right? Like the 12 times by the scale factor gives me that side there. So 12 times 1.67 gives me 12 plus x. 12 times 1.67 will give me 20. And then you can see, well, 12 plus what, the x being the what, 12 plus what would equal 20? Well, that has to be 8, doesn't it? So x has to be 8. So we have two answers there, so to speak, for this question here. All right. Cool. Now, for each of these pairs of similar triangles, we have to determine if they're similar, and if they are similar, we have to state the rule. So for this first pair, I can see straight away that I've got 1, 2, 3 sides that are the same, or not the same, but 1, 2, 3 sides on each. If I was to flip this triangle here, or rotate it around, you should be able to see that we have 3 sides that match up, like the 6 would match up to the 36, the 14 would match up to the 84, and the 12 would match up to the 72. They all have the same scale factor of times 6. So yes, all 3 sides are the same. So I would say yes, or same ratio, same scale factor. So yes, and it is true by side, side, side. And that's all I'd have to say. This one over here, we've got 2 triangles with some angles in them. And if we remember, in total for a triangle, all 3 angles have to add up to 180 degrees. So if we take this triangle here, we can see I've got 21 plus 105 plus something, whatever this third angle here is, plus something's going to give me 180. And so if I do 180 minus the 21 and minus the 105, the missing amount is 54 degrees. And you can check that, right? You could do the 21 plus the 105 plus the 54, and if that gives you 180, then you've got the right answer, right? We've got the right thing. And so now I can see, well, hang on, this unknown angle here, it's no longer unknown, it's 54. So now I've got 54 and 21, and that matches up with 54 and 21 here. And if you guys remember your notes quite well, you remember that we don't need all three angles, we only need two. So this pair of triangles is also similar, and the rule is by angle, angle, or you could have said triple angle. Either way, I will give you the marks on the test, okay? All right, question 9. Liam wants to borrow $25,000 for his business. He's got two options. We want to know which option results in less interest, okay? So let's sort of compare the pair. We got option 1, we got option 2. For option 1, we need to find P, R, and T. And we're going to do the same for option 2. Now, in either option, we're borrowing $25,000. So for both options, we've got the 25 grand. Now, for option 1, we can see that we are looking at an interest rate of 2.6%, which is 0.026. And that's for 28 months, which that's a problem for us. We need that in years. So if you guys remember to go from months to years, we divide by 12 because it's 12 months in a year. So 28 divided by 12 is going to give us 2.33 years. And now using this value, and this value, we can plug it into I equals PRT, and we would get 25,000 times 0.026 times 2.33, and in total that is going to give me 25,000 times 0.026 times 2.33, $1,540.15, or 50 cents, sorry. All right, let's see if we get more or less from option 2. So for option 2, my rate, well, that's going to be 3.2%, which is 0.032. And my time is going to be 20 months, which once again, that's a problem. I need that in years. So we're going to go 20 divided by 12 to get me to years. So let's have a look. 20 divided by 12, that gives me 1.67 years. Once again, I equals PRT, replacing P with the 25,000, replacing R with the 0.032, and replacing time with 1.67, multiplying those three together, 25,000 times 0.032 times 1.67 in the calculator, we get $1,336. And so if I'm comparing the pair of option 1 and option 2, I can see that option 2 is less interest. So option 2 is less interest, which is better for a loan, right? So if we were picking between these two options, we would go for option 2, all right? But yeah, it says which option is less interest? Option 2 is less interest. Awesome. All right, Ella invests $6,000 at 5.1% per annum simple interest. She wants to earn $1,020 in interest. How long will it take to the nearest whole year? This one, we should hopefully have written down in our page of notes that time equals the interest amount divided by P times R. Or if you have a calculator that can't do fractions, you might have it written down as time equals I divided by P times R, like that. Either way, it's going to work, right? We need to find I, P, and R in the question. So let's label that. I equals, P equals, and R equals. So we're investing $6,000 at 5.1% interest per annum interest, and we want to earn $1,020 in interest. So the starting amount, which is the principal, remember, the starting amount is that $6,000. So the starting amount is the principal amount. Then the amount of interest that we want to earn, well, that's $1,020. So we'll put that in for the interest. And then the rate, well, that's 5.1%, which is 0.051. And so now for my formula, I'll need these three numbers here, right? Going back to our formula, t equals, I'm going to use this one here, but if you were using this one here, it is still the same process. You're just replacing I, P, and R with the things we found over there. So we'd find t equals 1020 divided by 6,000 times 0.051. Let's see what that gets us. 1020 divided by 6,000 times 0.051. That gets us 3.33 years. Now this gets a little bit tricky now because it says, how long will it take to the nearest whole year? And obviously, if you were rounding 3.3 to the nearest whole number, you would round it to 3 years. But after 3 years, do we have enough money, right? Have we made that $1,020 in interest? Well, the answer is no, right? If we need 3.33 years to make that much, then after 1 year, 2 year, 3 year, we still haven't made that amount of money. So we end up actually rounding it up to 4 years. Right? Because after 3 years, we wouldn't have enough, but after 4 years, we've got too much money. And with money, we'd always rather have too much than not enough. So our answer is 4 years. All right. If you are still watching the video at this point, these questions here, I threw them in the practice test to try prep you guys for probably, a very difficult one anyway. These are definitely quite challenging questions. I'm going to go through them very slowly. If you've been watching along so far, maybe pause the video for a sec, have a quick drink of water, all that kind of stuff, so that you're ready to fully focus. So we actually have two questions here. We've got a question there and a question there. So I'm going to focus on question 1 to begin with, and first thing I want to note is that when it says the length AB, that's referring to the distance from A to B. So the length AB is that distance there, or you can see they've highlighted it for us with the question mark. Okay, so that's what they want us to solve for if the two triangles are similar. So if the two triangles are similar, we're solving for AB. So we need to determine if the two triangles are similar. So let's have a look how we could work that out. Now, as with any questions with triangles on top of each other, right, like this one, we like to redraw the triangles, okay? And we want to redraw them so that they're facing the same way. So if I look at the shape of this big triangle, right, it looks a little bit like that. I want to redraw that for the smaller one, right? I want it to look pretty similar. So I'm going to do that again, but just, whoop. Sorry, guys. I'm going to do that again, but just try and make it a little bit neater. All right, so we've got... Why is it playing silly games with me? Sorry, guys. Try that one more time. I'm not sure why it's doing this. Okay, there we go. So we've got that triangle there, but we're looking at the smaller version of the triangle. So the thing I'm trying to redraw specifically, guys, is this little triangle in here. And I want to redraw it. Oh, whoops. Sorry. Bring that back. And I want to redraw it in a way that looks the same as the big one. So we're redrawing the little one in the way that looks like the big one. So that means that I want this angle here where this angle here's ended up. So that angle there is going to end up here. And we can see that in the corner, well, we can see like, hang on, I'll get rid of that. If we look at that little triangle, we can see that sort of like opposite the angle. So like facing that way, we have the 1.5 side. So if I look at my triangle over here, opposite the angle facing the 1.5 side, I have, opposite the angle, I have the 1.5 side. And then there's sort of like a long side and a short side touching the angle. On the shorter side, we have the 2. So if I look over here, this is my shorter side. So on the shorter side, I have the 2. And one last theme, we have the A on the corner that is sort of furthest away from the angle. So it's sort of over here. Okay, so now I've redrawn that triangle the way it is there. As for the larger triangle, over here I have 6 and then I have 2. So in total, and we can even, actually, just to make this a little bit easier for you guys to follow again, we can even get rid of this triangle in here now, right? And we're just going to look at this as if it's the big triangle. So like I was saying, across the bottom, we've got 6 and then 2. So in total, we would have 8 across the bottom. So I'm actually going to replace that with 8. And then over here, we've got 1.5 and then an unknown amount. So I'm actually going to replace that with 1.5 plus the unknown amount that I'm solving for, right? So it's 1.5 plus the unknown amount. All right, and so now we've done the hard part of this question. Really, that's the hard part. Now we're going to be solving for, actually, first we need to prove that they're similar. But we have done the hard part of the question. If I bring this back, you'll see that there is an angle. I just can't zoom in anymore, guys, sorry. But there is an angle in this corner here, right? That little, maybe I can highlight this better with a little red dot. That angle there in that corner there is shared by both the small triangle and the big triangle, right? It's shared by both the small triangle and the big triangle. So on the small triangle, you'll see that it's the angle opposite the long diagonal side. So it's actually this angle here. And if I label this now again, if I get rid of that again, and if I label this now on the big triangle, it shares those two angles there. So those two are the same. And so we can say that yes, it is similar. And it's by angle, right? Or by angle. Because we can see that we have these dots here indicate that those angles are equal. And then they literally share the same angle too. So that other angle is also equal. Okay, so the if part of this question, if the two triangles are similar, yes, they are. So now we just need to solve for the question mark or the length of A to B. Looking at it now is going to be more like questions you're a bit more familiar with. So we're going towards the triangle with the unknown value. To find our scale factor, we're looking at a pair of corresponding sides, which I'm looking at that pair there. The side with on the arrowhead goes on top, so it's going to be 8 over 1.5, which is 16 over 3, or if you throw that in the calculator, you will get 5.33, right? And so now, using this to solve for the unknown, we can see that 2 matches up with this side. So the 2 multiplied by the scale factor, which is 5.33, is going to give me 1.5 plus my unknown amount. So 2 lots of 5.33, well, that's not exactly a nice number, right? That's going to be, I'm running out of space here, so I'm just going to do it over here. 2 lots of 5.33 is 10.66. And so we then have that 1.5 plus an unknown number gives me 10.66. So essentially what I need to do is take 1.5 off of 10.66. And you can see that gives me 9.16. Okay, and so I have rounded partway through this question, so this is only approximate, but that would be the length of the unknown side. It would be the length of AB. Awesome. All right. Now this question here, when I picked it out for the practice test, I didn't realize that to solve for AC, we actually have to use Pythagoras. That was not intentional. You do not need to know anything about Pythagoras for this test, but we will still solve it, seeing as I have given it to you guys. The rest, like the first part of the question, though, leading up to this bit, is all still highly relevant. Okay. So, looking at this triangle here, I'm asked how many similar triangles are there. So looking at this triangle here, I can see that there is it's not letting me draw, hang on, one triangle there. Right, there's one triangle there. There is a triangle here. Right, you guys can see that. And then there's also a triangle here. Okay, and so my goal is going to be to redraw these triangles in a way that they're all facing the same way, because at the moment they're all flipped and rotated and they're looking a bit weird. So essentially though, we've got three right angle triangles. So we're going to have a slightly larger right angle triangle. Okay. We're going to have about a medium-sized right angle triangle, and then a slightly smaller right angle triangle. All right, so let's start with the big one. That would be this one here. You guys can see we've got that right angle there, hence why I've got the right angle over there. I've also got 5 over here, right, on the back side, and then on the top, I've got 3 plus the length from C to B, right? C to B, that length there, plus the 3 would give me this entire length, wouldn't it? So I'm going to label it as, 3 plus the length from C to B for the big one. Then if I'm doing this middle one, so I'll get rid of all this now. If I'm doing this middle one here, the like medium-sized one, we've actually got not much information at all, really. Although you'll see that this angle here is shared by both the big triangle and by the medium-sized one. So we can label that here with a dot, right? We know that they're equivalent, okay? For the smallest triangle, we've got this triangle here. Now I can see on the like long diagonal side, I have a 5. And then on the shorter of the two other sides, I have a 3. And once again, I have an angle here that's shared with the big triangle. This angle up the top here, that is shared with the big triangle. So I can label that 2, right? And I'm going to use 2 dots this time because it's a different angle. Those 2 angles there are equivalent, okay? And so now if we were to look at these these triangles, let's take let's actually label them, right? Let's just call this triangle A. Actually, let's just use numbers. Triangle 1, 2, and 3. If I look at triangles 1 and 2, I can see that I have an angle there that matches and an angle there that matches, right? The 2 right angles are both 90 degrees, and we know that they share that other angle. So we could say that triangle, and actually, I'm just going to leave that highlighted, sorry guys. And actually we are going to use a little bit of notation here too. So bear with me for a second here. But we can say that those 2 triangles are similar is the end goal here. But the way I'm going to label this, see how for the big triangle here, we have the letter A in that corner, letter B in that corner, and D in that corner. And then for the medium-sized one, we've got A in the top corner, B at that side, and C below the right angle. So the way I actually am going to end up writing this, I'm going to use this symbol here, which indicates a triangle. I'm going to say triangle DAB, which is the big triangle, right? It's triangle 1, is similar to, that symbol means similar to, triangle ACB, the medium triangle, or triangle 2, ACB. And the rule that tells us they're similar is that they have 2 angles in common, okay? Then, if we have a look at the big triangle and the little triangle, we can see they have that angle in common and that angle in common, right? So once again, these 2 triangles are going to be equivalent. I am going to label the little triangle as well. So if we look at the little triangle, I should note there is a right angle there. if we look at the little triangle, we can see we've got C below the right angle, D up the top, and A over there in the corner. So I've found out that triangle DAB is also similar to triangle DCA by the same theme, by angle angle. And now that we've worked out that both triangles are similar to the big one, that tells us that, well, by just, a bit of logic, the medium, like triangles 2 and 3, the medium and the small triangle, well, they're also similar, right? If they both have the same angles as the big one, well, then they've got the same angles as each other, right? So triangle DCA, also by angle angle. So answering part A, how many similar triangles are there? 3. All right, we've got 3 similar triangles. Now we're asked to find the length BD. All right, we're asked to find the length BD. Now, in order to do this, I am finding I'm finding the length from here to here, right? Finding that length there. I can see that I have a corresponding side here and here. So the small triangle and the big triangle are going to be the 2 I'm focusing on for this one. And then as for how I'm going to be able to use that, I need a scale factor. And so I can see to get a scale factor, I've also got a corresponding pair here of numbers, which is awesome. So that's going to be my green ticket. So that tells me that scale factor is going to be equal to, well, we're going this way, right? We're solving for the one up the top. So scale factor is going to be equal to 5/3, okay, which is approximately 1.67, okay? And so then to get the the size of DB, the unknown side, so DB, so going to that side now, it's going to be 5 times the scale factor, so 5 times 1.67, which gives us 8.35. Okay, and there's no units in this question or anything, so we will run with that as 8.35. And DB, I've written it the other way around, but DB and BD mean the same thing. It's just the line connecting the two. So that is my answer there for part I. For part 2, so this is what I was saying at the start. You actually need to use Pythagoras' theorem to solve this. If you look at this triangle here at the bottom, triangle 3, you'll see that we have 2 out of the 3 sides. I'm not going to go into it because you don't need to know Pythagoras for this test. But using Pythagoras, we could say that the length CA is equal to 4. Okay. You don't need to know how I got that. If you happen to remember from last term, great. But once again, you don't actually need to remember that. Now for part 3, we have to find the length of AB, which is this length here, or it's that length there. And I already know that my scale factor, from the small triangle to the big triangle is 5/3, right? It's 5/3. So if I happen to know, and we've found that CA, and you can see this is C to A here, we know that CA is 4. So we can just go from there to there using the scale factor. So AB, right, the length we're finding, is going to be equal to 4 times the scale factor, which is 1.67. So 6.68. Okay, cool. And that would be that last question answered too. All right. I know these last 2 that I've thrown in here are quite difficult questions under the challenge problems. I do not expect that you guys, will all completely understand this, but if you've at least been able to grab most of the rough ideas, it will, set you up for doing the best you can on the test. This is, these questions here are above the level of what you could expect when you sit your test, but still really good practice, and it's one of those things, if you can do these questions, it sets you up really well to do whatever it is in the test. Okay. And as per usual, if you have any questions, please ask me in class. Thanks, guys.